So now that we know the basics of what a loop is and how to create them, especially counted loops, let's figure out how we can actually apply them today, to apply them to useful scenarios for starters. So our objective is to apply loops to work with arrays, and then we're going to use loops within loops, nesting loops, if you recall what the term nesting means. So loops with arrays. Arrays, as themselves, are amazing things. They let us group vast, huge amounts of data and refer to them very simply, just using a single variable name. But there's still a lot of manual effort. For example, if we have an array of numbers and just want to display them, you still have to go through every single one of them one at a time. And this code needs to change if your array size actually modifies. So here's a simple example. I have an array of 3 items, 3, 4, 5, with integers 3, 4, 5. And to display them on the screen, I need 3 lines of code. Now imagine for a second if I actually do the same thing but extend it to 1,500 numbers. I don't know how much you're going to want to do that. That's a lot of effort for a very poor result. So obviously, even with arrays, even though it simplifies the process, it doesn't speed it up a lot in all scenarios. So our goal today is to rectify that situation. We can use counted loops to automate this whole process. Again, that's why we started programming in the first place. So looking at this, imagine I have that same integer array, 3, 4, 5. Now I'm going to use a for loop to go through every single element of that array. I'm iterating through the array is the way we say this. I'm iterating through the array. What that means is I'm going to loop through and look at every single element of the array. How? Well, the key here is that counter variable, I. That variable is not only going to act as our counter variable, but we're also going to use it as the index for our array. Now pause that for a second. What does that mean? We're going to use I as our index? Yeah, that's exactly what we're going to do. But of course, this only works if the values of I are valid for our index values. What does that mean? It means every single possible value of I in our loop must coincide with our array range. Now, what is our array range? It's all the valid values of indexes or indices. What does that mean? Well, that means everything from 0 up to nums.length minus 1. Well, what's nums.length here? Well, it's 3. So minus 1 is 2. So our valid index values are 0, 1, and 2. Now look at our for statement. We say start at I is equal to 0. So far, so good. Keep looping by 1 as long as I is less than 3. 0, 1, 2. Oh, that's all of our index values. So this works perfectly. If we look inside, that 3-line program, that 3 lines of output just got turned into 1 line, one simple output statement that used nums at I. Oh, that's much better. That's much, much better. Let's keep going with this. So that 3 it's a magic number. We don't like that. It's a magic number because that 3 actually represents something. It represents how many elements there are in the array. And if we ever wanted to change the size of our array, we would actually have to modify this code. That's nothing we want to do. So how do we fix this situation? Do you know? I hope you do. I hope you figured that out by now. Basically what that means is we simply need to change the 3 to nums.length. Then the code will work no matter what the size of the array is. So if I gave it an array of 100 elements, 2 million elements, 1 billion elements, this for loop would never have to change. Now imagine if you put this loop inside of a subprogram and you just pass that array in as a parameter. Well, now all of a sudden you can output any array as long as you're using that .length property of the array, and it will work no matter what. Doesn't matter what data type it is, as long as your parameter is set up to accept that proper data type, it will work. This is fantastic. This simplifies all of our work. So that 3 lines of code from the previous slide can turn into 2 lines of code, whether it's 3 elements or 3 billion elements. 2 lines of code. Awesome. So let's keep going with this. So we have a blank skeleton over here on the right-hand side for a program. Let's see what we want to do. I want you to write a program that asks the user for 100 numbers that are stored in an array. Well, in order to do that, the first thing we need to do is we need an array to store those 100 numbers. Okay. Now I want to display those numbers and calculate the average. Now, that's fine. That means we're going to need a sum variable in order to add up all the numbers, and then we're going to need a variable to store the average. Now I want you to ask yourself for a second, how long would this code be if we didn't have arrays? Well, first of all, we would have 100 separate variables just to represent the data. And then we would have to go through a very long sequence of additions. So let's say those variables were called num1, num2, num3, num4, all the way up to num100. That would be a very long addition statement. Probably something you don't want to write. How long would this code be without loops? Well, let's see how long it is with loops. Now, looking at this, the first thing I need to do is get the data from the user, because I'm asking the user for 100 numbers. Now, I don't want to do this one at a time. I don't want to ask them one at a time. I want to loop through it. So here I've created a loop, and this loop is doing the same thing we did on the previous slide. I'm going to use I as my index into the array. So I have to make sure that all the values of I represent all the possible index values of my array. In this case, from 0 all the way up to nums.length minus 1, which is why we say less than nums.length. If we said less than or equal to, we would get an error because nums.length is too big. That'll give us index 100, but there is no index 100. The biggest index is 99, if you remember, because remember they start counting at 0. So here we go, 0 to 99. And for every iteration of the loop, we're going to do the exact same 2 lines of code. Prompt the user for the number. Please enter number 0. Please enter number 1. Please enter number 2. And for every one of those, we're then going to store that number inside of our array. Nums at 0, nums at 1, nums at 2, and so on and so forth. So with 3 lines of code, we were able to do what would take us 200 lines of code. Even if we knew arrays and we didn't know loops, that would take us 200 lines of code. 2 lines for every single number. Well, that's a pretty good savings. But we're not done yet. We still need to calculate or display each one of these and calculate the average. So we're going to run another loop. And this loop has the exact same structure because I'm looping through the exact same array. So I have the exact same for statement. You'll notice that I'm reusing the variable I. This is okay because remember, because this variable was created inside of the for loop, it gets destroyed as soon as we are done with that loop, which means it's safe to use that same variable name again. So down below here, all I'm doing is I'm taking the current element that we're looking at, nums at I, and adding it to the current value of sum. So sum is basically like a running total. It starts out at 0, then it's going to add whatever's in at nums 0, and then nums 1, and then nums 2, and so on and so forth. And as well, at the same time, I'm also displaying the current value of that element. So number 0, colon, whatever nums at 0 is. And this is another 200 lines of code we just saved. Okay, well, we still need to calculate the average. That's a pretty easy calculation. We already have the sum, we just have to divide it by our length. Now, because average is a double, and I want to make sure I keep all my decimal places, I've cast sum and I cast nums.length to doubles just to make sure that the data that I get back is accurate to all the decimal places. And then I just display the final result. So this program here, which looks to be, let's see, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines of code, just replaced probably about 500 lines of code if we didn't know arrays and we didn't know loops. That's a pretty good change in efficiency. I love it. So arrays and loops are 2 of the most powerful tools you now have in your toolbox. Everything that you want to do going forward you should be thinking about how you can put loops to the task, as well as arrays when possible. So what about nesting? Now, we talked about nesting before, if you recall. We talked about it when we first learned about if statements, and we talked about how if statements are just control structures, things that give control to the user over the flow of the program. They control the flow of the program. Well, a loop is just another control structure. It controls the flow. And then in the case of a loop, it brings that flow back up. It completely brings it back up. Huh, okay. So what nesting is just simply having a control structure inside of a control structure. An if statement inside of an if statement. A switch inside of an if inside of a switch. But this can be extended to what we just learned, which is loops. Which means we can have loops inside of loops. We can have loops inside of ifs inside of loops, and switch statements in there as well. There's no rules against that. as long as you can keep it clear in your head, you're pretty safe. Pretty safe. Now that being said, you can technically nest as many loops as you want, but it can get pretty confusing and with more than 3 nested loops. Not only that, it can get pretty expensive on the CPU, and you're going to see why in a second. So let's start with a simple logic test. How many times, looking at this code here, will the words hi, yo, and bye be displayed each? How many times will we see each one of these on the screen? Think about this for a second. Pause the video and try and analyze that. Okay, so looking at this, we got to look at the way the loops are created. So we have this outer loop here, this for I loop. And it starts at 1, it keeps looping as long as I is less than 3. So that means I is 1, I is 2. So there's only going to be 2 iterations of that outer loop. Inside, it says keep looping, start at 1, and keep looping as long as j is less than 4. So j is 1, 2, and 3. So that means there's 3 iterations of the inner loop. So does that mean we're going to see hi once, yo 3 times, and bye once? No. Why? Well, this is what we're actually going to see. We're going to see hi, yo, 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 hi, yo, 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 bye. How did that work? Well, what does this tell us about the number of times inner loops execute relative to the outer loop? Well, it tells us something very important. Inner loops will fully complete all their iterations for each one iteration of the outer loop. What that means is it's coming in here, it says for I is equal to 1. Is I less than 3? Yes, it is. It's a 1. So it's going to come in, it's going to display hi. And now it's going to start another loop. J is equal to 1, and keep looping as long as j is less than 4. And it's only going up by 1. So j is 1, loop. Come back up, j is 2, loop. J is 3, loop. J is 4, nope. Continue on with the rest of the program. So it went through all 3 iterations before it went down to the bye. Oh, I should have another bye in here, actually. That's a typo on my part. I'll fix that. And then it comes back up to the top, and it does it again. Now I is 2. And it does the whole process again. I'm going to fix this right now before that bothers me. So that should be, there we go. There we go. Hi, yo, 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 bye. Hi, yo, 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 bye. There we go. So that's what it actually should be. So we can see that the inner loop will fully iterate completely for every one iteration of the outer loop. So that's why I say when you start doing nesting with loops, you can see that this can get exponentially large in terms of how many times the inner loops actually will execute. Quite a bit. So a common application of nested loops, I would say probably the most common application of nested loops, is when you need to analyze a grid of data, something that's based on rows and columns. So like a game of chess or tic-tac-toe, or a spreadsheet of data, anything that relies on rows and columns. So it actually is pretty straightforward. Imagine if we had a grid of 3 by 3, like a tic-tac-toe board. Okay? So I might create a for loop that looks like this. For int row, you notice I'm not using I and j this time. The reason why I'm using full names is because it'll help me keep things clear in terms of which loop represents rows and which loop represents columns. So in the first loop I said for int row is equal to 0. Keep looping as long as row is less than 3. That means row is 0, 1, and 2 are all the possible iteration values there. Okay? It's going to go inside and it's going to display the current row. And then while it's on that current row, it's going to look at every single column. Column 0, column 1, column 2. And then it's going to continue on. So what this means is, for each row, we're going to look at each column from left to right. Then go on to the next row. So imagine this, you're going to be on row 0, column 0, column 1, column 2. Row 1, column 0, column 1, column 2. Row 2, column 0, column 1, column 2. And we end up with something that looks like this. So this, if you're picturing a grid-based board, it's looking at the top row, and then it's going to go through every single cell in that row. And then it's going to go down to the next row, every single cell. Next row, every single cell. And that's the way it actually iterates. And this is probably the most used representation of nesting when it comes to for loops. So that's not the only kind of nesting we can have. We can have nesting of selection statements inside of our loops as well. It doesn't always have to be loops inside of loops. Remember, it's just control structures inside of control structures. So you can also put these things inside of our loops. Why? Well, let's find out. So in this case, we're going to display all the numbers between -3 and 32 that are divisible by 5. That's what my comment says. I can see that. Now here's my loop. We're going to start our number at -3. We're going to keep looping as long as number is less than 33, which means 32 is our biggest number. And we're going up by 1. So -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, all the way up to 32. And for each value of number, so for each counter variable, we're going to test it. We're going to do the modulus of 5. Remember, modulus means the remainder of a division. So if the remainder of the division is 0, that means it evenly divided. So that means that this is a divisor of 5. So what are all the divisors of 5 from -30 all the way up to 32? Well, we're going to get 0, 5, 10, 15, 20, 25, 30, which is what we end up seeing. So you can see that you can actually have selection statements inside of here, and that's probably going to be used a lot when you go forward within the rest of the course. So that is how we can apply these loops to something pretty useful. I would say the biggest application here is using our loops with our arrays. You're going to use that a lot going forward. Good luck, and let's keep moving on. Next class, next lesson, we're looking at conditional loops.